Okay, guys. So did anybody get the prime factorization of the 147? 3, 7, and 7. Now, if you didn't remember this, that's okay. But when you guys used to learn about prime factorizations in like 4th or 5th grade or whatever, you would write it like this: 7 squared times 3.
Couldn't you also do 7 square root 3?
Careful, no, the 7 square root would mean that I'm making the 7 smaller. But if I want a bigger number, I want to do 7 times 7. But it makes sense to me why you would think that, because most of the time, probably the last time you've done a factor tree without a square root was probably elementary school. In the last couple years, this year, last year, and Sec 1 also, the only time you ever did these was when you were simplifying a square root. So it makes sense why you would relate the factor tree to the square root. Does that make sense? Okay, good question. Good. Now, next year I've already decided I'm going to change this because I think some of the people were confused on question 2 because they were thinking that they should be able to get the 7 and the 3 somehow relating here. That wasn't really what I wanted you to look at. I'll change the numbers for next year. More, I want you to realize that the way that it looks is the same, right? If I've got the same factor times itself twice, right, then it's squared, and then it's times the 3. Does that make sense? What form is this polynomial in right here? Intercept form or factored form? Very good. Okay, because it's all the way factored out so I can see its intercepts. That's where those names come from, okay? Now, here's the main point of what I wanted you to get in this first 2 questions. When I found these 2 factors, did I get them from the 21 or did I go back to the 147 and try factors? Sure, I'll repeat it. So I said when I got these factors, right? Because on this one is the one I gave it to you, okay? Did I get them from the 21 or after I got the 7, did I go back to the beginning and start trying new numbers on that? You got it from the 21. If I asked you to factor 40, right? What's something 40 breaks into?
22.
Okay, 20 and 2, 4 and 10. Either one that you do, once I get those, do I break down the 4 and 10 or do I go back to the 40? Very good, right? So once I divide a factor out, I use that quotient to find new factors. I don't go back to the original. Does that make sense? Okay, any questions so far? Okay, this is review from last time. Just to check your work, I think it was remainder 6. If you did the division right, I think you got a remainder 6. Any questions? Okay, if you need more help with that review from last time, then you're welcome to come in lunch or after school. We're here till 3 every day, okay? So keep that in mind with the dividing, okay? Determine whether, we're only going to do 2 of these. So we're going to do A, because I don't think we need all 4 of them. Because I had a lot more people turn in last time's homework than has been the norm. Okay, so let's just review last time, okay? So let's divide this out. So x plus 2 and what's the first piece I put in? There we go. Okay, if you don't need me to walk through it, then feel free to jump ahead. Okay, I crossed off B, so you've got more work room. So then, if I know I'm trying to get, or I need to get to x cubed, x times what is x cubed? Well, that's the x squared. Then I remultiply. Okay, then I know that 2x squared, but I need to combine it like terms with the negative 2x squared. So negative 4x. Remultiply. Do you mind taking your spinny chair over there and going hovering by Ashley and Maya? They were both gone last time. So you could ask them little questions while I review this for everyone else a little quicker. Yeah, Maya and Ashley right behind her. They were just gone last time. And I figure if you just kind of hover there, then I can move a little faster for everyone else while you catch them up on the dividing. Is that cool? Yeah. Okay. Then I have, 3? Right? Okay, is that one a factor?
Yes.
Okay, so I want you to, yes, read.
Where'd you get negative 4x squared?
Sure. So I know that I got the 2x squared from doing x squared times 2, right? Then I know that these two are going to have to combine together to be that one. So then I knew that since I know it's a negative 2 or a 2x squared and I know I want negative 2x squared, that's where I got the negative 4x squared. Does that make sense?
Yeah.
Okay. Okay. And, all right. So we're not going to do it on this one, but this is the whole point of this. Okay. From our opener, let's connect it. If I asked you to factor this all the way, it's a cubic. So how many parentheses would it have? 3. Okay. Because I got remainder 0, right? Then I would then want to divide into here, right? Because it's like when I divided the 7 into the 147, I go off the 21. You with me? Does that make sense? Okay, let's try D. Let's try one more. D. I hope D doesn't work. I want one that doesn't work. It does? Ah, man. Maybe I want us to do B then. Ooh, my bad. This one, because it doesn't work. Okay, we're going to do this one. X cubed, mostly because I'm trying to make a point here with this. Hey, it's already the number I want it to be. So what do I put here?
0,
You got it.
which is like the number 8 on the homework.
Yep. We call that stuff a placeholder. When something's already like what I want it to be, you can just put a 0 in. So then I have 0, right? And 0. But I need it to be negative 5x, right? So that's how I get here. So negative 5. 5. Do you see how this one has an extra box? This one has a remainder of what? So then let me ask you this. If I were trying to factor this, would this up here, this quotient, be of any use to me? No, because there was a remainder. Imagine like if I had 147 and let's say I didn't give you the 7 that went into it. So I'm like, oh, well, I'll just try 3. Wait, that worked. No, I'll just try 9. Okay. Well, if I try 9, I got 16.3 repeated when I just typed it into my calculator here. That doesn't mean I keep using the 9 or the 16, right? It didn't work. It has a remainder. I move on with my life. That's the main point of what I'm trying to get to you guys when we factor these cubics and 4th degree polynomials. You guys good? We're doing all right? Okay. So here is the, okay, well, I'll say that in a second. Okay, let's go to this one. How many roots do you expect this function to have on number 5? Why? Because it's cubed, okay? Very good, because the degree is 3. If I know the degree is 3 and it has 3 roots, then remember that means I'm looking for 3 parentheses, right? Well, the easiest type of factoring is quadratic factoring. You guys have been doing that forever, right? But I can only factor quadratic, so I have to divide things out until they are quadratic. Now, on all these ones I gave you yesterday and today, do you see how I gave you a factor already? Well, I don't want it to be like old school factoring, like with the 147, where you're like, well, I'll try 5, and then I'll try 7, and then I'll try 3, right? I want a way to be able to get those guesses quicker. Does that make sense? Okay, so this is known as the rational root theorem, okay?